Hello everyone, welcome back to my channel. Today I'm going to talk about the beam design using ETABS and hand calculation per ACI code. And this is the model that I'm going to use in this video. And we're going to use this beam. So before we start, please don't forget to subscribe and hit the notification button. And if you like this video, please put a thumb up as well. Okay, so I already ran the structural analysis, so I'm going to perform the concrete design, and we can check the result here. And I will go to diagram, and we're going to use this internal force to put it in the hand calculation script in order to find the result and compare with the result in ETABS. Okay, so this is the script in the MATHCAD. So in this beam design, we have the flexural design, shear design, and the torsion as well. So first we need to import the beam property. We have the width, depth, concrete property, and we have the man bar property here, and the stirrup to resist the shear and torsion. And this is the cover, and we have the effective depth of the concrete as well. So next we need to import the internal force. So we have the bending moment, shear force, and torsion. And for the bending moment, we have the top rebar, and we have the bending moment for the bottom rebar here. Okay, next we can go to calculation, and for the bottom and the top rebar we use the same method. So I will only show you one calculation. So first we need to input the phi, which is the strength reduction factor, beta 1, and you can find this in the code, and this one as well. Okay, so for this video I will show you 3 books. So the first one is this book. You can read it for the beam design. This is a good book for concrete design per ACI. And next one is the ACI code. And one more, you can go to help and documentation, and go to concrete frame design and select which code that you use. And in this video we're going to use the ACI 19 here, and this is the ETABS manual, and you can go to beam design here. Okay, so now we back to our script. So once you know all this, you can compute for C, and I use the same formula here, so we can compute for A. So once we know the A here, we can compare with the A maximum, so we can know that the rebar need the compression reinforcement or not. But in this script I only cover the single reinforcement. So in the case that this section is double reinforcement, you need to add more script by yourself. Okay, so once we know this value, we can compute for the required reinforcement. So for the required reinforcement, you can use this formula. So once you have the required reinforcement, you need to compare with the minimum reinforcement, and you can find this in the ACI code, and I will show you. You can go to beam and reinforcement limit, and you can look at the value here, and next you can find the final value of the required rebar here, and I will show you the provide reinforcement layer. And for the bottom rebar we use the same method. So next we can go to shear reinforcement. So for shear we have the strength reduction factor for shear, and I use the minimum value after the effective depth. And next we need to find the VC and Vmax, and we can compare with the internal force. So when the shear force is less than this value, it means that the concrete section doesn't need the minimum reinforcement. But if it is bigger than Vmax, the concrete section need to be increased. But if the value is in between this value, it means that the concrete section need minimum shear reinforcement. And for the minimum reinforcement, you can look at the ACI code as well, which is this value, and value here. Okay, so next we can compute for the require shear reinforcement, and we can find the maximum spacing as well. And next one we can compute for the torsion reinforcement. So for torsion we have to compute for this value. I will not cover this in detail, but you can read in the design code what are these. And the next we need to find phi t tx or phi t threshold and the phi t crack. So we need this value to compare with the internal force. So you can look at the condition here. If the TU is bigger or equal to phi t crack, the torsion can be reduced. So this only apply on the compactability torsion. For the equilibrium torsion, you cannot be reused. And the next condition is if TU is less than phi t threshold, you can ignore the torsion, but otherwise you cannot. So once you know all these conditions, you can find the required reinforcement. So we have the transversal reinforcement and the longitudinal reinforcement. So once you know all this, next step you need to check shear plus torsion. So you can use this value, and for the minimum value here is shown in the ACI code here. So this is the maximum spacing. So this is for shear reinforcement, and this one is for torsion reinforcement. Okay, so now we need to collect the results. So we have the top and the bottom rebar, and we have the number of rebar for the flexural design and for the torsion design, and I divide the torsion reinforcement into two. Half of the area go to the top and the other half go to the bottom. And Next we have the total area, and this is the result. I think you can look at the summary value here. So we have the flexural design, torsion, and this is the total longitudinal reinforcement. And we have the stirrup reinforcement, we have shear torsion and shear plus torsion. We can go to ETABS here, and I will show you the diagrams again, and we can look at the moment first. So we input the value here, and we don't need to use the negative value. And for the shear, this value, and for the torsion, this value. Okay, so now we have the internal force. The script here will run automatically, and we can check the result here. And I'm going to compare with the result here in ETABS. So we can check the flexural longitudinal first. So this is the require, and this is the require for the bottom. And next we can check the torsional longitudinal reinforcing. So you can check here. So the value here divide by 2. So I can take this value and divide by 2. So the result here almost the same. And next we can check the total longitudinal reinforcing. So for this value, you can sum this value with this value, divide by 2. So you will have this value, but it's not the same, but I think it's okay to use this. And next we can check shear reinforcement. So this is the value you can compare with this one. And next one is the torsion. So the result here, the top value is the stirrup reinforcement, and the bottom is longitudinal reinforcing. So you can check the value here. It's quite the same. And next one, we can check the shear plus torsion reinforcing. And this one. Okay, so this is the demand capacity ratio, and you can check in order to adjust the provide reinforcing to make it more economic. Okay, so this is it for this video. And for the beam design, it's not only just this calculation. There's more formula, more case that you can apply. You have to check in the code. You will see there's a lot more case than this one, but normally we design the beam to resist only the flexural, shear, and torsion. Okay, so I hope you guys enjoy this. Thank you so much for watching. I'll see you guys in my next video.